Till now, we have done the concept of differentiation in mathematics, but let me tell you that the derivatives or differentiation can also be applied in economics. In economics, if we apply the principles or the functions of derivatives, that it helps us in the calculation of elasticity of demand, total revenue, marginal revenue, average revenue, etc. Now, the point is how we are going to calculate all these things with the help of derivatives. So, let's discuss that. The first topic which we are going to cover today is elasticity of demand, and it is expressed as ED or mu D, right? Okay. So basically, if we all know that law of demand represents the relationship between price and quantity, right? And we all know that the relationship is in inverse form. So according to this law, we can say that there is an inverse relationship between price and quantity. That is, with the increase in price, the quantity demanded will go down. Okay, and with the decrease in price, there is increase in quantity demanded. So we can say that quantity demanded is a function of price. So it means that quantity demanded is dependent variable, and price of a product is considered as an independent variable, right? So we can also say that if there is change in quantity demanded because of change in price, we can say that there is elasticity of demand, right? So how we can represent it? We can explain the elasticity of demand as mu D is equals to change in quantity divided by change in price multiplied by price divided by quantity, and this is represented by negative sign. Okay, why there is negative sign? Because there is an inverse relationship between quantity demanded and price. Okay. So next concept, this is my first concept, that is of elasticity of demand, and this is its formula. Second concept is slope. Second concept which we are covered today is slope of demand curve. Right? So slope of demand curve means that what is the rate of change in quantity demanded due to change in price, right? So this is basically slope, and it is calculated as minus dq divided by dp. This part of elasticity of demand is represented as slope, and again we have this negative sign. Why? Because there is an inverse relationship between the price and quantity demanded, right? Third formula which we are going to cover is total revenue. Total revenue is equals to price into quantity, right? Or we can say P into Q, right? So this is the formula of total revenue. And the next formula is average revenue. So average revenue is equals to total revenue divided by quantity demanded, right? Or I can also represent it as the formula of total revenue is P into Q and divided by Q. So it is equals to P, that is price. So we can say that average revenue is equals to price. Now comes the concept of marginal revenue. So fifth point is marginal revenue. So marginal revenue is equals to d by dq of total revenue, or you can write it as d by dq into pq, because the formula of total revenue is pq. And if you see here, there is p into q, that is here we apply product rule. And if we open this thing, then what we will get? P into derivative of Q plus Q into derivative of P, right? And this is equals to P plus Q into dP by dQ. And here the derivative of Q is equals to 1 and derivative of P is equals to 1 with respect to Q. So that's why we can write 1 into dP by dQ or just dP by dQ. Okay. Now, like revenue, there are some formulas which help us in calculation of average cost and revenue cost. So let's discuss those formulas. Like if we have to calculate average cost, then in that case the formula will be total cost divided by quantity, right? So I can write it as TC divided by Q, right? Where TC is total cost and Q is quantity demanded. Marginal cost is, it is derivative of total cost, right? So here if you see that we have taken dx in denominator. Why? Because it is with respect to x. Sometimes it can be taken as d by dq of total cost, right? Why? Because in some questions, q may be taken as x. Like quantity, instead of taking quantity as q, they will take quantity as x. So it means d by dq and d by dx, they are same, right? Because they take quantity not as a q but as an x variable. Fine. Sometimes it is asked to calculate the slope of average cost curve. So in that case, and we know that the formula for average cost is equals to TC by Q. This we have already done, right? So when we have to calculate the slope, what is slope? Slope is the rate of change in average cost due to change in output. Okay, so the formula will be derivative of average cost. So I can write x also in order to avoid confusion. Instead of q I can take x also, right? So q or x. So I will take x. So whenever we have to take the derivative of ac, it gives me derivative of dc by x, right? Now here we will apply quotient rule, and we know the formula of u by w. So here it comes to slope is equals to x into derivative of total cost minus total cost into derivative of x divided by x square. So this gives me x into derivative of total cost is marginal cost. Okay, this we have already covered. See this point, seventh point, that derivative of total cost is marginal cost, right? So x into mc minus total cost. So minus total cost into 1 divided by x square, right? And instead of this TC, we can write AC into X. Why we write this? Because we know that AC is equals to total cost divided by X. So if we have to calculate total cost, we have to multiply it to average cost with X. So in the next step, what we will write, x into marginal cost minus average cost divided by x square, or I can write it like this, that 1 upon x into marginal cost minus average cost. So this is equals to slope of average cost curve. And according to economic laws, the minimum of average cost function and slope of average cost curve should be equals to zero, right? So it means half of mc 1 upon x of mc minus ac is equals to 0. How we can say that? This is economic according to economic laws, right? For minimum average cost function and slope of average cost for curve should be equals to 0. So if we did this, then we will get mc minus ac equals to 0, or we can say that mc is equals to ac, right? So at the minimum point of ac, at minimum point of AC curve, average cost curve, right? Clear? So this shows the relationship of average cost and marginal cost. In the same way, we can also show the relationship between the average revenue and marginal revenue. So let's go above. We have already written the formulas of average revenue and marginal revenue and total revenue. So whenever there is asked that we have to show the relationship between them, that is average revenue, marginal revenue, and elasticity of demand, we know that marginal revenue is equals to P plus Q into dP by dQ, this part, right? So if we continue this further, and what we will do, like marginal revenue is equals to P plus Q into dP by dQ. Now, if we take dP by dQ on one side and shift it to other side, or we can take P on other side, we can get minus Q dP by dQ is equals to P minus marginal revenue, right? We can get this. And the next step is that divide and multiply right hand side with P. Okay, so I can get minus Q dP by dQ is equals to P minus marginal revenue into P divided by P. If I cancel this, I will get 1. So there is no change in the answer. Now the next step is that I have to take this P on left hand side, right? So it gives me minus Q by P into dP by dQ is equals to P minus MR divided by P. And we know this thing that P is equals to average revenue. See this. P is equals to average revenue. So what I get here, average revenue minus marginal revenue divided by average revenue, and this is equals to Q minus Q by P into dP by dQ, right? Clear? So this is my right hand side. Now talking about the left hand side, if you remember this formula which we have done first, this this formula, and this is the formula of elasticity of demand. It is P by Q into dQ minus dP, right? P by Q into dQ by dP, right? So what we will do, we will reciprocate both the sides. Reciprocate both the sides. Now, what we will get, we will write it in this form, minus P by Q into dQ by dP is equals to average revenue upon average revenue minus marginal revenue. And this is the formula of elasticity of demand, right? So I can write here elasticity of demand is equals to average revenue upon average revenue minus marginal revenue. So this way we will able to show the relationship between elasticity of demand, average revenue, and marginal revenue. I hope the concept is clear till now. In the next part of the session, we will cover some practical question related to these formulas.